Good afternoon and welcome to Design Master Training. My name is David Robison. Today we have Brian Muir as our guest trainer. He has an electrical consulting company located on Vancouver Island in British Columbia. He's been using Design Master for 2 years now. He's recently done 2 presentations for Autodesk-sponsored virtual community meetups. Today he is going to be talking about using Design Master and custom families for automating your Revit workflow. If you are attending the training live, you can ask questions in the chat box. If you are watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. So Brian, thank you for being here to do a little training for us, and I'll hand it over to you now.
All right, thanks, David, and thank you, everyone, for dropping in today. So we're a small electrical consulting firm located on Vancouver Island in British Columbia, Canada, as David said. And the project I'm using as a basis for the talk today is a real one. It's a small community school located on one of our islands near here called Hornby Island. So the project's substantially advanced since this architectural screenshot I'm showing you, but this is one that was just handy. So a little community school with about 5 classes and, a gym and all the rest of it. So, and if you're interested, that is located, there it is, Hornby Island, right in beautiful British Columbia. And my office where I'm talking to you right now is right here. So let me bring up Revit here and show you what's going on. So I've compiled a sheet showing just items of interest to us for this talk. So what we've got here is a little section of the school floor plan. So I'll be talking around this, and the roof where we're locating mechanical equipment. So I want to show you how we put mechanical equipment in our drawings and have our schedules and panel schedules automatically update using our custom libraries and Design Master. And here you can see the schedule of motorized equipment. So this is all, a typical Revit automated schedule. However, a number of these parameters are out of Design Master. So I'll just show you that in the Properties menu. If we go to the fields, you can see that 3 of the parameters here, DM equipment FLA, MCA, and MLCP are right out of Design Master, along with a number of our custom parameters. We also have a schedule of non-motorized mechanical loads, again, drawing a different set of parameters. Things like FLA aren't as relevant to us, so we just list the load. What I'll do is go ahead and add a heat pump to the roof here and show you how that brings into our schedule and also how that'll affect the panel schedule. And let me, I think we're going to want the main PDC schedule on the sheet, so let me just get that. Okay, there's our main switchboard schedule as well. Okay, so I'm going to go ahead and go to the roof plan and drop in a mechanical heat pump. So I can go to Systems, Mechanical Equipment, and in my Properties menu here, I've got a whole selection of parts to choose from. I can narrow that search down by typing in search terms, like heat pump. Okay, this is the one I want, this Aramec 16.5 ton. That's what's been specified by mechanical. So I'm going to go ahead and just get this out of the way here. Okay. The first thing I do with it is I give it a designation. So we have this custom designation parameter. The reason we're not using type mark is because for some families, we want designation as an instance parameter, and for others, we want it as a type parameter. And having it as a custom parameter lets us be a lot more flexible. So in general, you see we're using custom parameters and not so much out-of-the-box parameters for a lot of things. But I'm going to call this heat pump 1. Okay. Okay, so this is our Aramec 16.5 ton. So next thing I'll do with this is I'll connect it to a panel. So I'm going to connect it to the main PDC. If we look at circuit properties here, we can see this is on a breaker. It's set to 15 amp presently, which for sure isn't right. 3-pole breaker from the PDC. And if we go over to the PDC schedule, we can see that right now this says other roof, not too helpful, and it's a 15 amp breaker. So let's go ahead and calculate the project using Design Master, see what happens. All right, there we go. Heat pump on the roof, 200 amp breaker. That's perfect. Also, if we go to our schedule here, now we've got heat pump 1 right there on the roof, FLA 130 amps, MOCP 200 amps, looks good. We can put in comments here if we want. But with a couple of clicks, we're most of the way along with that device. So in a similar way, we could do a resistive device. So I will drop in a baseboard heater in here. Not that we're using any in this project, but just for the sake of example. Again, search baseboard. Okay, you see I've got a lot of different options here, but we'll pick 208 volts, 1000 watts. So right now this baseboard isn't connected to a panel, so I'm going to go ahead and run it to panel A, which is my main house panel, so to speak. And if we look at the panel A schedule, I've got a HVAC device, 2-pole popped up here. So once again, running Design Master, calculating the project. And we have baseboard heater project space at 15 amps. So that seems pretty good. And there it is there in our motor schedule, our non-motorized schedule. So let's go ahead and create a few more baseboards here. Just to illustrate a point. So I'll just throw them out in space. And we'll take this circuit and add these baseboards on there. Now we'll go back to our panel A schedule. We can see it's still 15 amps, but using Design Master, calculate the project. Okay, this guy's just upgraded automatically to 20 amps to account for that extra load. So we've got 3000 watts, 15 amps on each phase, 1500 on each phase. So far, so good. If anyone has any questions so far, just type them out in the chat window and see if I can deal with them.
All right, so there's a question, how does wire sizing work?
Okay, wire sizing will be handled by the lookup tables you configure in Design Master. So under these wire size tables, well, that's the basic wire size, but what you want is to customize this table here. So this will, based on your ampacity, will draw appropriate wire and conduit. So does that answer the question? Anyway, I'm sure if you have any questions on this point, David can set up a training session for you on it. It's pretty straightforward, really. Okay, I'll move on.
I'd say there's a follow-up question that did answer his wire sizing question, and then he wants to know where does that show up on the plans? So I guess where are you showing it in particular?
Okay, we often don't show it because we call for wire size to the breaker and not reduce for mechanical loads. However, for this big heat pump, we might actually want to reduce it. So we could add a field to this schedule to show wire size as a call out from Design Master. So let's take a look at this heat pump here. And if we look at the properties, we can go down into Design Master properties, and here's the wire callout right here, DM_feeder wire callout. So it's a pretty trivial matter to add that to this panel schedule, this schedule. We can go fields. There it is. Okay. And you can see it. Got a bit of overlap in here. I'll just shove this out of the way for a sec. You can see there's the wire callouts for all these mechanical devices right there. So hopefully that answers the question.
It did. He said, thank you. And he said that looked very slick.
Yeah, no, my pleasure. And hey, it's the underlying software that makes this work. I mean, give David and his team a lot of credit here. Okay, we discovered, much to our delight, a couple of months ago, another use for this capability. So it's just exploiting the same features you're seeing, but for a slightly different application. So here's a little kitchen in this kindergarten classroom, okay? And right now we haven't put anything in here. I'll take this guy away. So we're starting from scratch, right? So we've developed a family of appliance devices. So I'll show you how that works. I'm going to go System, Electrical Device. And I know we need a refrigerator here. So I can go on the list and search again for refrigerator. And we've got it coming up under this wall mount specific AC devices. And I'll talk about what this LH means in a second. But I'll go ahead and just drop this on the plan right there. Okay, so that is a refrigerator outlet. It knows it's a refrigerator outlet. I will also go and drop down another one, which I'm going to have as a range. Okay, so a 208 volt range. So here's a range, a 208 volt receptacle, right? Let's get a circuit tag on both of these. So right now we're not circuited either, right? So we're gonna throw those on our house panel. So panel A. And we have this, our little tag has different box sizes. So I'm sure you guys have your own systems for tagging, but you notice also we have a wipeout in there, a masking region. We find that makes our plans a lot more legible. So anyway, the refrigerator's gone on circuit A2 and the range is on A49. So taking a look at our panel schedule, we can see A2 just says receptacle K2 classroom, and A49 says, a 2-pole receptacle, both at 15 amps. So you guys probably know where this is headed. We'll go back to Design Master, calculate our project, and see what happens. Okay, now we got a range in the description, and the breaker went to 40 amps. The refrigerator still at 15 amps. So I don't know you, but I think that's really cool. And we used to have the odd problem where our drawings would go out, and have the range on a 15 amp circuit or things like this. And we get calls from the contractor asking us if we really expected them to wire a range on a 15 amp circuit, and we found that a little embarrassing. So really, with our new workflow, we don't get those kind of questions anymore. So I'd like to show you how this works under the scenes now, and it's really pretty simple. So let's take a look at this range family. So this is really in 3D. It's just a outlet box that, depending on your selections, will be either vertical or horizontal, and will be single gang or 2 gang. And as we cycle through different options, you'll see it change size. So a dishwasher is single gang, but if we go to a range, so there's our range outlet. So how this works in Design Master is like this. Design Master has a family edit capability, which you may not even know about. In fact, we didn't understand this for a little while until we kind of discovered it one day. And really, if we paid more attention to the documentation, we probably would have known about this earlier. But what it lets you do is set up basic information about your load. So in this case, we're just an other branch circuit device, so there's not a lot of information to be set. But in each instance, you can set a circuit description right here. So we've got, a dryer is set to dryer, and the range is set to range. So this is how the circuits get their information, get their naming information. Now, the load information isn't managed directly in Design Master. We manage it just in the regular family type properties. So we know a range is 6,000 VA versus a refrigerator, which is, 700 VA, we call it. Let me show you next the mechanical family. So if we go to that heat pump we talked about, we can see how that's built. So this one in DM family, this is a branch circuit device equipment connection, okay? So it's a different animal than the other device. The equipment connection gives you a bunch of useful parameters appearing under Design Master. So here we've gone to the cut sheet for that heat pump, and we pulled out an FLA of 130, minimum circuit ampacity of 150, and MOCP of 200. And we're using this rule, the 175% BCSC or less than MOCP. So this is a design master rule. You get a bunch of options, but that's the one we choose. And that'll lead to a breaker size of 200 because it'll calculate out based on FLA and actually trim it down to the MOCP. So that's what Design Master will do. And Design Master will also read this heat pump circuit description coming in and use that in the circuit in the panel schedule. So that's really how that works. And we have many families that have more than one type of heat pump. So, 1 ton, 2 ton, 5 ton. And we just go ahead and we configure them all as individual instances, family types, with different models. And actually, let me show you one of those. Like if we look at, I think this family here will have multiple types, I think. Yeah, so this is a 3 ton, 4 ton, 5 ton, right, with varying loads. Here we have our power parameters actually pulling out of Design Master's FLA parameter. Our current parameter is pulling out of the Design Master parameter. So we aren't setting the current in this menu, in the family type menu. We are instead deciding and setting all those current ratings here under Design Master properties, so that when we set up Design Master, it automatically derives into the family type and then derives into everything else that in turn connects to. So the 8 ton has an FLA of 45, the 5 ton has a FLA of 25, etc. Away you go. All of them use the description heat pump. But you see, Design Master lets you override each one individually with this little drop down here. So that's how we set up multiple options. And if we go in our project, we can play with that. So let's take RT1 and look at the properties here. So RT1 is this 8 ton guy. Okay, so currently RT1 has, okay, so this is it here. So it's a 60 amp breaker, okay? Suppose we get a memo from mechanical during design and they decide they're going to reduce that guy. They're going to reduce that guy to a 4 ton, okay? So there we go. So 839 breaker is still 60 amp, but that's just because we haven't calculated it yet. You see it's dropped to 35. Now, I might have a problem with my setup of that part because really it shouldn't be giving me this warning. So I probably have a mismatch between MCA and FLA and MOP on the setup of that part, what's leading to this. But anyway, Revit's telling you there's something you better look out for because there may be an issue. So we would investigate that and likely just update our family. Questions to this point?
Yeah, there's another question. He's saying it looks like you have mechanical equipment in the same model as your electrical. Does Design Master support separate MEP trade models?
Yeah, okay, so we're an electrical design firm. So we don't do mechanical. We take all our electrical, all our mechanical designs in from different mechanical engineers in different formats. And we replicate their parts on our drawing. However, if you're an MEP firm, you can do something similar just by either sharing one Revit model or using, hopefully, if you're working in Revit, so too is your mechanical division, doing coordinating, a copy monitor. But what I'd encourage you to do is get together with the mechanical team and build a set of common libraries that work for both of you. So when they draw it in, it has the right pipe size, deck size, model numbers, and also design master parameters all configured for your use as the electrical team. Does that answer the question?
Yeah, I think that answers the question. And just to add on to that a little bit, coordination between disciplines is always a tricky point with any sort of this BIM software. It's the holy grail of getting everybody working together, but it works as well as you actually talk to the other people in your company, which surprisingly can be difficult at times.
Yeah. And if you can set up common libraries, we've been talking with the one firm we work with that uses Revit about us developing a set of families for them, which will contain all the electrical information we need. And then we would expect to link in their model and use Copy Monitor to then make those devices live in our project. Because I don't believe we can schedule, we wouldn't be able to schedule properly on elements in a linked model. We would have to Copy Monitor them in. So, or the other thing we could explore is just sharing the same model with them, but I think that's going a little too far outside what I'd be comfortable with right now. So that's really the thrust of the talk is if you set up your mechanical and appliance device families with all the design master parameters, you'll see this automated workflow where your panel schedules and your device schedules all do what they're supposed to without any user intervention. So that's something that's been huge for us. Saves us a lot of time, saves us coordination errors, and I hope you find that useful as well. And if anyone has any specific questions about how to build this, I could get into that now for a while or offline. There's actually two things I could talk about that aren't strictly design master, but I think users would find them interesting. So the first is this symbol legend is an automated Revit schedule. So if you aren't doing this or unaware of how to do it, I'll just explain. This field here is called the type image. It's a standard Revit parameter. So as we add new devices, this schedule will update automatically. So if we just go behind the hood here real quick and look at the fields, we can see the first field is this type image field out of Revit. And then there's a description and a mounting height, which we throw in just standard parameter on our families. And we also have behind the scenes a parameter called include in legend, which we can turn on and off. So to stop parts we don't want to appear in the legend. So that's something that's worked out really well for us. And just quickly show you one part. For example, this is a USB receptacle. So if I edit the family and we go to the type properties, we look at the USB duplex with USB under type image here. Not that one. I'll just show you a standard one. Here's a standard duplex receptacle, and we look at type image. It's just this guy. So we load in this set of images that we created, and you can assign any family type to any one of these, and then pull it out in a schedule. So that's the useful thing. The other thing I wanted to mention is you may have noticed I haven't been concerned about attaching items to walls as I drop families in. This receptacle, for example, I can drag anywhere, which isn't normal Revit behavior. And that's because this job is not based on a Revit model. What you're looking at underneath is actually a DWG file that's linked in. So we have a workflow that lets us operate on a architectural model that's not done in Revit. but we still use Revit. So I'll give a talk on this for the Autodesk community. But if you're still in a world where you're using AutoCAD for AutoCAD source projects and Revit for Revit source projects, I'd strongly encourage you to look at unifying your workflow with Revit for at least your building projects. Because that for us has been a huge money saver. And that's it, David. Oh, I'd also mention, David and I have been talking about this for a while. I've mentioned to David a couple times that I see value in establishing a set of shared parameters for electrical that are common across multiple users, and that would allow those users to share content. I really haven't got any traction with this idea in the general Autodesk community, but I think perhaps the Design Master community is a more focused group and probably generally more understanding of the problems we're dealing with. And it seems to me this community could be a good one to set up a set of common shared parameters. And with Design Master, we already have a starting place. We already have parameters for things like FLA, MOP, etc. So with another dozen or 20 parameters, we could really capture everything we need to know about electrical devices and then share them amongst our community. So if you're interested in that idea, maybe get in touch with me through David.
Yeah, so if you guys are interested in sharing any of your families, doing some coordination between companies so that you're not all recreating the wheel, definitely you can contact us at support@designmaster.biz, and we can get you in touch with Brian to work on that project.
Yeah, just to illustrate the point, I could send you one of these RFA files, but they wouldn't work for you because you'd have to overhaul the parameters to match your parameter set, which is a real waste of time. So if my current parameter and your current parameter are the same, and you can't use the out-of-box Revit parameters because they're hopeless, as David could go on for an hour probably about that. So you need custom parameters, and if your parameters are different than my parameters, we can't talk to one another, which is really stupid. So,
got two more questions that have come in. One, which is what we were talking about earlier. Are you doing any fault current calculations or voltage drop calculations in Revit?
Yeah, interesting. David and I just talked about that. I have a project where I have to do some fault analysis, so I'll be, for the first time, venturing into that. But so far, I haven't really needed to do that on any of my projects, but I'm getting into that. It looks pretty exciting the way once everything's configured properly, it's just appears to be a pretty quick operation to generate fault analysis. But stay tuned, I guess.
All right. Yeah, I just took control from Brian here. I'm going to run his computer for a moment because I can talk to that a little bit, because it's actually doing the calculations in Revit is really straightforward, assuming your model is well defined. So we are going to test Brian here and see how well defined his model is. So if you go to panel edit, you'll get this dialog here, and he's got everything connected up nicely. So you can see all your panels. You define everything in Revit. You make the connections in Revit. So that's all standard Revit functionality. And then we use these definitions here to actually do your fault and voltage drop calculations. So taking LPT here, we can go down to the fault section, and this might not be necessarily where you would have the fault from the utility, but at some point the utility gives you kind of your starting fault value. So you specify that in Revit, and then from there it'll do the calculation with that as the starting point. So if we just go over here to our fault schedule, Design Master will put together a default schedule, and we run the calculate, and it'll update all the values based on that 65,000 starting fault. Now, there are a number of... Do you do any of the feeder sizing with Revit right now, Brian?
Generally not.
Okay. Yeah, so if you look here, all his feeder sizes, he's got like number 12 feeders. So Brian, this project is not well defined, so the calculations are not going to work out. But basically, you come into Design Master. If you get your panel sizes set, we'll size your feeders, and then the fault calc and the voltage drop kind of fall out automatically based on that.
Yeah, I think that main bus size on the PDC not being set properly is screwing everything up.
Yeah, so the PDC doesn't have a bus size and whatnot. I'm not going to mess with your project too much here.
Yeah, that's okay. This is a throwaway file now.
Oh. All right, well, in that case, sure. So, if we set this to 100, we'll actually get a number 1 wire, and then, we're going to get...
That's actually going to, if it matters, that'll be a 600 amp PDC.
Oh, okay. It's going to be even bigger. But so we resize it, we get your fault calc numbers. So the software does calculate it. You just got to get your feeder sizes set basically based on your panels being set properly.
Yeah, thanks. Yeah. Okay.
And just so you're aware of the other features in there, you got to get your feeder size set, obviously. So put this feeder size right. And then we have a couple options for your XR ratios, and particularly for transformers. Do you have any transformers in here?
Yeah, LPT is a transformer.
LPT. Okay, so on the transformer, you have the option to set the impedance and the XR ratio for that transformer as well.
Yeah. Hey, David, just a comment here. You see up above the LPT, we have a large round junction box. And that is just a family that we use to describe a junction box on our site plans. And it needs to be electrical equipment class because we want to be able to control it in Revit's visibility section as electrical equipment. But it'd be really nice if it didn't show up in the panel edit and if Design Master didn't pay any attention to it at all. So maybe I'm asking for a feature, but just pointing out that that's a bit of a thing that not all electrical equipment is relevant to Design Master, or should even appear.
So for the electrical equipment, there's an additional setting, which is a subtype or the category or something of that nature.
Yep. Mm-hmm.
There's panel board, switchboard, transformer. There's also, I think it's electrical switch or something of that nature.
Yeah.
If you change it to that type, it will disappear from this list.
Yeah, okay, and I can just set those to switch, right? Yeah,
because basically you've got it marked as a panel, and Design Master says, "Well, it's a panel. You probably should show it."
Okay, sure. I'll get my content guy to fix all that. That's
So swap that out to the different subcategory, and then it shows it.
Okay. Yeah, David and I, for everyone else, David and I have had a few conversations about the Revit electrical equipment classifications and how they're pretty inadequate, and whether or not Design Master can overlay some more sophisticated classification on top of that. But that's, just interesting conversation.
Yeah. There's another question. Any features in Design Master for AutoCAD that are not available in Revit yet? And I'll go ahead and just field that one for you. And there's a lot that we can do in our AutoCAD software that is not in Revit. So for those of you who are using our AutoCAD software and are looking to transition, it's not going to be a straight transition. For example, all of the feeder and service calculation stuff that we've done, the multifamily dwelling things, none of that is available in Revit. Revit has some of that built in, but it's not to the degree and sophistication that we've got done in our AutoCAD software. That's the biggest one. There's lots of other little features, just things that we've had a chance over 20 years to get into AutoCAD that Revit doesn't quite have yet. The other big one is that our AutoCAD software has selective coordination in it. That's not currently in Revit, but that is coming in the next release. So we are getting selective coordination and breaker curves and all that good stuff in the next release. Brian, thank you for presenting. We definitely appreciate you sharing your knowledge. To everyone attending, thank you for watching today's training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.